Okay, so in lesson 11, we're going to continue what we've been talking about with similar triangles. So what we're going to be doing today is kind of combining the sides and the angles, looking at both, determining whether two triangles are similar or not. So on your note sheet, let's look at the first example there. We have two triangles. Notice we have the really small one labeled with primes, so we know that's going to be the new shape, and it's darker, a little bit darker. And then the bigger one, A, B, C, that was your original. That's where you started with. And part A simply asks, are these two triangles similar? And explain. So we know nothing about the angles. The only thing we know is about the sides. Now remember, we've been talking about scale factor. How do you get from one triangle to the next? Well, I can determine from right here, I know the length of BC and I know the length of B prime, C prime. So to figure out the scale factor, remember we take the primes and divide it by the original. So we're going to take 2 and divide it by 8. Well, I can simplify that and get 1/4. Now remember, for them to be similar, that has to be true for the other sides as well. Now I know AC, but I don't know AC prime. And I know AB prime, but I don't know AB. So just based on this, I really don't have enough information to determine if they are similar or not. So that's what we're going to write on part A. We don't have enough information to know. We would need to know the lengths of the other sides, or they would have to tell us that these lines BC and B prime C prime were parallel in order to determine if they were similar or not. So moving on down to part B, now it says assume line BC is parallel to B prime C prime. So these two lines right here. With that information, can you say that the two triangles are similar? Now, knowing that these two lines are similar, that now tells us that because they are parallel, that means that the corresponding angles are congruent. So that means C is congruent to C prime, B is congruent to B prime, and A is congruent to A prime. And from what we learned yesterday, that if you have two sets of angles that are congruent, then your triangles are parallel. So we'll say yes, they are similar because they have two sets of corresponding angles that are congruent. So we figured that C was equal to C prime, B was equal to B prime, and that was all because those two lines were parallel. Okay, part C then wants us, based on that information, knowing that they're parallel or similar, they want to know how long is AC prime. So that is this little chunk right here. Well, I know that AC, this whole piece, is 6. To figure out the new length, remember we have to take the original times the scale factor. Well, if you will refer back to part A, let me click back up there, we determined that our scale factor was 1/4. So down on part C, I'm going to take 6, which was the original, and multiply it by the scale factor 1/4. Okay, you can cancel the 6 and the 4. I'm going to divide them both by 2. So the 6 becomes a 3, the 4 becomes a 2, and you get 3/2. And I'm going to change that to a mixed number. 2 goes into 3 once, and I have 1 left over, so that would be 1 1/2. Okay, in the last part of this question, determine the length of AB. So here, we know AB prime. We want to know the original length. So remember, to get the new length, we had to take the original times the scale factor to get the new. Well, this time we know the new. That's 2.7. I know my scale factor was 1/4, which as a decimal is 0.25. And I don't know the original. That's what I'm trying to figure out. So remember, to solve this, since the problem says x times 0.25, I'm going to divide by 0.25 and pull out my calculator here. And I'm just going to type in 2.7 divided by 0.25, and I get 10.8. So that's the length of AB. All right, moving on to number 2. Again, we have 2 different triangles. Part A, is ABC similar to A prime, B prime, C prime? And explain. So I've got a couple different sets of sides. I also have 2 angles. Well, I'm going to look at the angles first. To me, that seems easier. What we talked about yesterday is, are the 2 angles, if they have 2 sets of corresponding angles that are equal, then they'll be parallel. So we have A that's 59 degrees. A prime is 59 degrees, so those match up. I have B that's 92 and B prime that's 92. So since both of those sets are equal, then yes, they are similar, because they have 2 sets of corresponding angles that are congruent. And I'm even going to name those. Angle A is equal to angle A prime, and then I'm going to say that those were both 59 degrees. And then angle B was equal to B prime, and those were 92 degrees. So that covers part A. We know they're similar. Part B says determine the length of AC prime, which was right there. So in order to determine the length, I have to know the scale factor first. So remember, we take where we ended and divide by where we started. So I've got to pick 2 sides that I know where I ended and where I started. So I'll just look at A prime, B prime right here. So the prime, 5.12, and where I started, 3.2. And I'm going to pull out my calculator again and type in 5.12 divided by 3.2, and I got 1.6. So my scale factor is 1.6. So to find A prime, C prime, I'm going to take AC, which is 6.1, and I'm going to multiply it by 1.6. And again, I'll just punch that in my calculator. And so I find that the length of A prime, C prime is 9.76. So again, we had to find the scale factor by dividing where we ended by where we started, and then multiply that by the original length of where we were looking. Okay, part C on that problem, determine the length of BC. All right, so I know B prime, C prime right here is 8.96. So remember, we had to take the original and multiply it by the scale factor. Well, now I'm going backwards. So I'm just going to take where I ended, 8.96, and divide it by my scale factor, which if I look back, that was 1.6. And again, I'll just plug it right in my calculator here. 8.96 divided by 1.6, and I get 5.6 for the length of BC. All right, moving on. The last problem here asks you if the two triangles are similar and explain. So if you notice, they only give us one angle, so I can't say they're similar because they have two angles that are equal. So I'm going to have to figure out if it's got the same scale factor applied. So remember, we take where we ended, the primes, and divide by where we started, the regulars. So I'm going to take A prime, B prime, 10.58, and divide by the regular, 5.3. And then I'm going to do the exact same thing for B prime, C prime. I'm going to take that, the 11.66, and divide by 4.6. And I'm going to see what I get for each one of these. So I can use my calculator here. 10.58 divided by 5.3. And I get a pretty long decimal. I'm going to go ahead and round it here just a little bit. And then let's see if we get anything different when we divide the other one. 11.66 divided by 4.6. And you get 2.53. I'll round that up to 5. So you can see here that these have two different scale factors. So we're going to say no, they are not similar because the sides have a different scale factor applied to them. Okay, and that wraps up lesson 11. Again, we were trying to determine whether two triangles are similar or not based on a combination of the lengths of their sides and angles, if any of those were given to us.